And I'm going to take a few minutes on this video to explain a few things about what it's like to live in a solar-powered house. First of all the electricity in this house comes from the sun or a wind-powered generator, as you see, or from a gas-powered, propane-powered generator, auxiliary generator, which I'll show you later. The solar panels, of which there are 20, are on solar trackers, and they follow the sun during the day, beginning in the east in the morning and then following around to the west in the late afternoon. They require absolutely no maintenance whatsoever. They are on a photovoltaic cell which tracks the sun during the day. They don't track precisely in tandem. Sometimes they get a little bit out of sync, but they do track the sun, as you can see. There are 20 panels. They're called Kyocera K51s. They each put out about 51 watts. The power goes through those cables, underground, under where I'm standing, and down to the battery room in the house, where I'll show you later. It's stored as 24-volt DC and then converted to 110 AC in the house, so that everything in the house acts as a normal house does on a grid power. That is to say, in the house that you're probably living in, that's powered by a public utility, the power is the same inside the house as it would be in your house. The primary difference is that you want to try to be as energy conscious of everything in the house as you can. That is to say, you want to, for instance, use the dishwasher when the sun is shining. You want to use the dryer and the washing machine when the sun is shining, and not use those appliances that use a lot of electricity at night or when it's cloudy. There is battery storage in the house, but it's best to use that for other purposes other than running appliances. So we'll go into the house. Actually, we'll go into the generator shed, and I'll show you a little bit more there. There you go. Hi, okay, now we're at the propane-powered alternate generator. This shed is meant to protect the generator. It's all set up electronically so that if the batteries in the house reach a level where they are lower than 23.8 volts, an automatic signal goes to this generator, tells it to turn on, and it begins to charge the batteries and at the same time powers the house. Okay, we're taking a look at that propane power generator that I mentioned a minute ago. It's an 8 kW, that's an 8 kilowatt power generator. It is totally electronic, and I've put on it the most sophisticated oil filtration system that money can buy. Originally, when I first ran this generator, it was required and suggested by the manufacturer that I change the oil about every 30 hours. That meant during the summer, changing it every 2 or 3 months. It meant during the winter, changing it perhaps every 2 weeks. Since then, I've put on, as I said, this very expensive and very sophisticated filtration system. It now requires that I change the oil once a year. It's completely automated, and as I mentioned earlier, there is a signal when the batteries reach a critical level. There is a signal that comes from the battery panel, which I'll show you in a few minutes, that tells this to turn on and run for the proper number of hours to raise the voltage in the house to the level that it's required, and then it automatically shuts off. Other than keeping the propane tank full, which is done about twice a year, and changing the oil in this once a year, there's virtually no maintenance whatsoever on this generator. We'll go inside now and take a look at the battery system and the inverter. Okay, we're now in the battery room, which is just off of the garage. Here we have 12 24-volt batteries that hold about 144 amp hours of time for the house. The power coming in from the solar panels or from the wind power generator and from the propane generator all come into this what's called an Ananda power center. This power center is the initial, the first stage of the power storage. The power then comes out of here at 24-volt DC and is stored in these batteries until needed. As the house requires, the power then comes out of here and goes into this 4 kW trace inverter. Now this inverter is, as the name implies, changes the voltage from the 24 volt DC to 110 AC, which everything in a house operates on. This is basically the brains of the entire system. This does all of the interface with the solar system. It does, as I mentioned, outside, tells the inverter, tells the generator rather, when to come on, when to shut off, at what voltage to start, at what voltage to stop, at what hour to start and stop. It is truly the essence of the house, and does all of the sophisticated work in the house. Just to the left of that, I have here everything that you have in a normal house. The normal circuit breakers, the normal junction box, everything to the left of this is as it is in your house, wherever it is that you live. So the only thing that's different in this house is everything that's to the right of this box is 24 volt DC. Other than that, everything in the house is as it is in your house. The notable exception, as I mentioned outside, is that in a solar-powered house, you try, wherever possible, to be as energy efficient as you can. Case in point, the lights above my head, these are fluorescent, low-voltage lights that use about a third or a half of the power as an incandescent light bulb would use. So that's an example of the type of thing that you do in a solar-powered house. We'll go inside now and I'll show you some other things. Okay, we're in the laundry room of the house now. The laundry room is just behind, the washer and dryer rather, are just behind the camera. And in front of me here is the heating system for the house. I have in this black the bucket here the water softener, which requires putting a 25 pound of salt in every couple of months, and other than that, no maintenance is required. This is the in-floor heating system. The entire house is heated by this boiler, which is propane powered, and it circulates glycol through plastic tubes throughout both levels of the house, keeping the house warm. This is the hot water holding tank. Over here I have a water softener, which requires virtually no maintenance. That works in conjunction with this black bucket here rather, softening the water out of all the taps. The boiler, as I mentioned, is propane powered. I have low voltage circuits for all the zone control valves in each one of the rooms. Each room has a rheostat, just like it does in your house, and that electrically is tied into the solar system. So once again, I'm trying wherever I possibly can to use low voltage or low power on all my appliances. This room is virtually maintenance-free, requires no work whatsoever, and has very little electric draw. As I mentioned, the boiler is propane-powered, and therefore requires no electric draw, only propane. We'll go now into the study, and I'll talk to you a little bit about the stereo system. All right, we're now in the